Welcome to Math with Father. Welcome to Math with Father. Subscribe, like and share.
Hello class, in this video we are going to discuss what a logarithm is, the laws of logarithm and the properties of logarithm. Alright, so in our previous video I explained what an index is and how to write huge expressions or numbers in an index form. So in that video we said 10 times 10 can be written in an index form. So since we have 10 repeating itself twice, one of the 10 is picked, and then the number of times it repeats itself, which is twice, is written on top of it. Now 10 multiplying itself 10 gives us 100, and 100 can be written in an index form 10 raised to the power 2. So it was stated in that video that our 10 denotes the base. Raised to the power 2 also denotes the power or index or exponent. And then this large or bigger number also defines our result. So our result, which is 100, is equal to 10 raised to the power 2. This same index equation can be written in a logarithmic form. Now, what is logarithm? It's another way of expressing an index form. So this same index equation could be written in a logarithmic form, which is log of the result 100 to the base 10 gives us a result of 2, which is the power. Log of 100 to the base 10 gives us a result of 2. So which is writing this index equation in a logarithmic form. So this same log can be read this way: 2 is the logarithm of 100 to base 10. Now I'm going to give out some examples for us to write them in logarithmic form. We are going to convert the following index equation into logarithmic form. Alright, so our first index equation, we have 3 raised to the power 4 equals 81. So writing this in a log form, that will be log of our result. Now let's move back to check our result. 3 to the power 4 is giving us 81. So 81 is our result. Log of 81 to the base. 3 is our base, 4 is our index or power. So now we have 3 as our base equals the power, which is 4. The power, which is 4. So log of the result to the base 3 is equal to the power 4. Log of our result 81 to the base 3 is equal to the power, which is 4. The second question, log of our result, which is 32, to our base 2 raised to the power 5. So to the base 2 equals to the power. Base 2 is equal to the power 5. The next one, log of the result 36 to the base 6 is given as a result of 2. Log of our result 36 to the base 6 gives us a result of 2. The next one, log of the result 64 to the base 4 gives us a result of 3, which is the power. The next, log of our result. So with this index equation, the result is a fraction, which is 1 on 27. So we are going to write this as our result, and 3 as our base, and negative 3 as our power. So log of 1 on 27 base 3 gives us a result of negative 3. Log of 1 on 27 to the base 3 gives us a result of negative 3. The next question, so log of 1 on 16 to the base 2 raised is equal to the power, which is negative 4. Log on 1 on 16 to the base 2 raised to the power negative 4. The last one, log of the result, which is 1 on 36 to a base 6 raised to the power, which is the result 2. So log of our result 1 on 36 to the base 6 gives us a result of negative 2. Now these are the solution sets of this index form of this index equation. These are the logarithmic form of this index equation. Now we know how to write index equations into logarithmic form. In our next section, we'll be moving on to the laws of logarithm. Laws of logarithm can be derived from the laws of indices. So in indices, anytime we encounter this index form, a raised to the power p is equal to a result x. A raised to the power p is equal to a result x, which is also similar to 10 raised to the power 2 is equal to 100. So a raised to the power p is synonymous to 10 raised to the power 2, and x is also synonymous to the result 100. Another index can also be written this way: a raised to the power k is equal to y. So the same index form 10 raised to the power 2 can also be written this way: a raised to the power k equals 100, which is also in the form of y. Now, if we could recall from our laws of indices, we said the first law in indices was our product law. And with the product law, the operational sign between the index forms AP and AQ is multiplication. AP by AQ is equal to XY is equal to X multiplying Y. So from the product law, it states if the bases are the same, one of the base is taken and the powers are summed up. P plus Q equals XY. So from here, we are going to write this in a logarithmic form. So writing this in a logarithmic form, log of the result. Now xy is our result. Log of our result to a base, and a is our base, is equal to the exponent or index, which is p plus q. So from our first index equation, a to the power p equals x can also be written in a logarithmic form. So which is log of the result, log x to the base a is equal to p. And a raised to the power q equals y can also be written in a logarithmic form, which is log of the result y to the base a is equal to q. So let's move back and check. Log of the result y to the base a is equal to q. So from the log equation, log xy base a equals p plus q, we have p to be log x base a, and we have q to be log y base a. So from this equation, we are going to replace p with log x base a and then do same for q. So I'm going to repeat this same equation. And we have p as log x base a. So I'm going to replace p with log x base a. And we have q as log y base a. So log a log xy base a log xy base a is giving us log x base a plus log y base a. And this is our first law of logarithm. This equation in our rectangular box is our first law of logarithm, which is derived from the product law of indices. So what it states is anytime we have two expressions or numbers or terms multiplying, then the expansion of this is log of x base a plus. So if it multiplies, the operational sign between the two terms or expression is the sum or the additional sign. We are moving on to the second law. Now the second law also obeys the second law of indices, which is the quotient law. So with the quotient from the same preamble, we have a raised to the power p equals x, a raised to the power q equals y, a raised to the power p equals x, a raised to the power q equals y. So writing this in a logarithmic form, now we would be getting log of the result x base to the base a equals p. And doing same for the second one, log y base a equals q. So from the quotient law, the operational sign between these two index forms, the operational sign between these two index forms would be division, similar to their result. A raised to the power p dividing a raised to the power q equals x divided by y. So from the second law in indices, which is the quotient, anytime we have two index forms of with the same base dividing, one of the base is taken and the powers are subtracted. So we have p minus q equals x divided by y. Now this index equation is to be converted into logarithmic equation. So in a logarithmic equation, we have log of the result x on y to the base, which is a, is equal to the exponent p minus q. Log of the result x on y to the base a is equal to p minus q. Now, in our previous section, we stated that log x to the base a is equal to p and log y to the base a is equal to q. So from our right hand side of the equation, we have p, which will be substituted with log x base a. And we also have q, which will be replaced with log y base a. So we have p, which is now log x base a minus q, which is also log y base a. So log x on y base a yields log x base a minus log y base a. And this leads us to the second law of logarithm derived from the second law of indices. We are moving on to the third law of logarithm. Now, we are moving on to the third law of logarithm, which is also coined or derived from the third law of indices. So in indices, the third law called the power law, it states that anytime we have an index a raised to the power p, which is equal to a certain result x, we also have another power raised to the index form n. So a raised to the power p or raised to the power n. Now the unique thing here is raised to the power n, so I apply same to my result. Back with the notion on indices. a raised to the power p to the power n can be simplified in the form a raised to the power p multiplying n equals x to the power n. The same thing can be simplified as a raised to the power p n equals x raised to the power n. This same index equation can be written in a logarithmic form. So a raised to the power pn equals xn can be written in the log form, log of the result x raised to the power n to our base a is equal to the power pn. So from our third and then the first law in log, p was defined. P was defined as log x base a. P was defined as log x base a. So I'm going to substitute this p to the form log x base a. I have n multiplying p, which is log x base a. Now log x to the power n base a can or could be written in the form n log x base a. And this leads us to the third law of logarithm. The third law of logarithm. So these are the three laws of logarithm. The third law, which is log x to the power n base a, is written as n log x base a. And our second law, log x on y base a can be written in the form log x base a minus log y base a. And with the first law, which is log xy base a, is also written in the form log x base a plus log y base a. So let's move on to the last thing to be discussed.
Always do it on my own, so I gotta get through it. And the only thing I know is to love what I'm doing. Never give up, never slow, till I finally prove it. Never listen to the no's, I just wanna keep moving. Keep my head up when I act, head up, that's a fact. Never looking back, I'ma keep myself on track. Keep my head up, staying strong, always moving on. Feel I don't belong, tell my thoughts to move along. Push myself to be the best, die with no regrets. Live with every breath, see my message start to spread. And I had so many dreams.
Properties of logarithm. In indices, anytime we encounter this index equation, x raised to the power 1 is equal to x. Any number raised to the power 1 is the same number. So x raised to the power 1 is equal to x. Now let's convert this index equation to a logarithmic equation. Log of the result, which is x, to the base x is equal to the power, which is 1. Log of x to the base x is given as 1. So this is any number to the same base as the number is 1. Any number to the same base as the number is 1. So this is our first property. First property. for logarithm, the first property of logarithm. The next property in indices, anytime we encounter this index equation, x raised to the power 0 is also equal to 1. Any number raised to the power 0 is equal to 1. How do we write this in a log form? Log of the result 1 to the base x is equal to 0. Log of 1 to the base x is equal to 0. So what this means is log of 1 to any base is always 0. Log of 1 to any base is always 0. So example under this, we have log 1 base 2 is 0. So log of 1 to any base is 0. And this leads us to the second law, and this leads us to the second property of logarithm. Now let's move on. Log of a negative number to any base does not exist. Log of a negative number, log of a negative number to any base does not exist. So let's note this. Let's note this, that log of a negative number to any base does not exist. And these are the properties of logarithm. So we have two properties with this notice, that log of a negative number to any base does not exist. And with the second property, log of 1 to any base is 0. And with the first property, log of a number to the same base as the number is 1. Now we are going to solve illustrative examples which is connected to what we've already done on the laws and with the properties of logarithm.
till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. On we'll go.
Subscribe, like and share.
Melodies we haven't played. No, I don't want no rest. Echoing around these walls, fighting to create a song. I don't wanna miss a beat. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. On we'll go. We'll grow in number, fueled by them to see the horizon, turn us to thousands. And we'll grow in number, fueled by them to see the horizon, turn us to thousands. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go.
Always do it on my own, so I gotta get through it. And the only thing I know is to love what I'm doing. Never give up, never slow, till I finally prove it. Never listen to the no's, I just wanna keep moving. Keep my head up when I act, head up, that's a fact. Never looking back, I'ma keep myself on track. Keep my head up, staying strong, always moving on. Feel I don't belong, tell my thoughts to move along. Push myself to be the best, die with no regrets. Live with every breath, see my message start to spread. And I had so many dreams, then you hit your teens. Life ain't really what it seems, try to find out what it means. Always do it on my own, so I gotta get through it. And the only thing I know is to love what I'm doing. Never give up, never slow, till I finally prove it. Never listen to the no's, I just wanna keep moving. Yeah, I put out all this art, it's my only medicine. Yeah, everything I do, I'm just being genuine. Yeah, I'm sick of being screwed, feel my own adrenaline. Yeah, I do just what I do, and I hope you let me in, yeah. stable, oh yeah, no label, oh yeah, you know me. I have only a path, I'm lonely, but damn, I'm going to win. I don't want no fake love, I want the real stuff. Everybody listen up, cause I'll only say it once. I'm gonna show you all the path, if you want it bad. I'm gonna show you where it's at, yeah, how you can get it back. Yeah, cause I ain't never done, I'll be number one. Working hella hard until I get just what I want, yeah. Rises like the sun, yeah, fatal like a gun. Shooter's gonna shoot and I'm gonna shoot until I won, yeah. Always do it on my own, so I gotta get through it. And the only thing I know is to love what I'm doing. Never give up, never slow, till I finally prove it. Never listen to the no's, I just wanna keep moving. Yeah, I put out all this art, it's my only medicine, yeah. Everything I do, I'm just being genuine, yeah. I'm sick of being screwed, feel my own adrenaline, yeah. I do just what I do, and I hope you let me in, yeah. Grateful, oh yeah, able, oh yeah, I'm stable, oh yeah, no label, oh yeah, you know me. I have only a path, I'm lonely, but damn, I'm going to win, yeah.
Alright, now these are some trial questions, and it's my wish after watching the video you try your hands on these questions. So the first one, you have to simplify these expressions as your first exercise. So try your hands on, and the solutions will be provided in a short. I will do short on the solutions to these questions. After trying your hands on these questions, watch my short and then confirm your answer. So watch the short to validate your answer, whether you are correct or wrong. This is also a continuation of our simplified question, the first exercise. So this is a continuation of the first exercise. This is also another exercise, given that log 5 base 3 is 1.4650 and log 2 base 3 also gives us 0.6309. Evaluate these. So please use the laws and then the properties to resolve all these. And I'm going to provide solutions to this in a short. So after try your hands on these, watch the short to validate your answer. Now the third exercise, also simplify these. Also simplify these. And I'm still going to provide answers to all these questions in a short. So please watch my short, subscribe to this channel, and let's grow together as a family. The next exercise, simplify the following. I'm also going to do same, provide answers to these questions in a short. So please subscribe for more, subscribe for more, subscribe for more. And this is a continuation, of the fourth exercise. And I'm going to provide solutions to all these questions in a short. So please, whenever you watch any video from my account, move to the short category and then watch the solutions provided to all these questions and other aspects to make mathematics and science a reality. Thank you. So if this video was very helpful, please give me a thumbs up and put me on post notification. So anytime I drop a new video,
Subscribe,
you'll
like
be
and share.
notified, and we all grow as a family. Anytime I post new video, you'll be notified and we all grow as a family. Learning never ends. Learning never ends. I'm out. Thank you.